Okay, team, today we're going to compare equal, that's the thing on the top with the two equal signs, and dot equals, that's a Java method. This slide has everything that we're going to learn, so equal equals is built into Java. It's just going to check references or variables to see if they're identical. For example, two variables that reference the same object, those are going to be identical. And the dot equals method is something that people who are writing a class that they provide, and it should check if two objects are equivalent. So they might not be literally the same object, just equivalent. And this isn't specific to dot equals, but we can't call methods on variables that are null. We can't say null dot something. And that last piece is that we're going to always write our dot equals method to take in an argument of type object. And that'll allow the classes that we write to work a little bit better with some of the Java built-in library classes. Okay, so equal on the left means it has the same value, and we can use it to check for null or to check primitives. And then the dot equals on the right, that's where we check equivalence. And there we're actually going to look at the insides of the object to see if they meet our definition of equivalence, and we get to decide what equivalence means. Okay, so check out the main method that I've got here. I've got two int variables, x and y, they're both 3, and those two things are equal because the variables hold identical things. It has the same value. Now I've got another example where s1 is the string high and s2 gets set to exactly what s1 is. So even when we did that line, we got a copy of whatever s1 was and set it to s2's value. Set s2's value to be whatever s1 was. And those two things are equal, and we can see in the diagram that they literally reference the same thing. So those two values of those variables are identical. Those have the same value. In my main method here, instead of setting s2, I don't give it a value, and so it's going to be null. And I can check if s1 is null, it's not, that should be false, and I can check if s2 is null, it is. And actually it ends up being super helpful for us to be practiced at checking if things are null. And int is a primitive. The primitives are those 8 lowercase types that we've got. And with primitives, we always get a default value. It's not a reference, it's just the actual value. So for an int, we get a default value of 0. And since they're not references, they can't be null. And so since that's not even possible for it to be null, Java won't let us even check if it's null. Okay, I've got a main method here, and I want you to pause it now to try and draw what memory looks like after line 45. I think this is going to be good practice, and then we'll talk through the remaining pieces. Okay, so pause it and draw that diagram. Okay, hopefully you drew the diagram, and hopefully yours looks something like what we've got here. If you didn't remember what was in the dog class, what instance variables, that's fine, but it's got a my age. Okay, so the next thing is I want you to pause and write whether each of these things should be true or false. So that's lines 46 through 52. Come up for each one what you think it should do. And then you should pause, but I'll keep going. And just as a reminder, we can go one level of abstraction up, and those are just pictures of stuffed dogs. And they're actually different stuffed dogs. They just happen to be equivalent. They're not identical, although maybe I've just copied and pasted the pictures, so technically they are literally the same dog. But big picture, D1 and D2, those are identical values. And then D3, that one's equivalent. So that one will be dot equals. Okay, so if we look at our solution, D1 is equal to D2. D1 and D3 and D1 and D4, those are not the same. Then we get to define what equivalent is, but certainly if things are equal, they should be dot equals. So line 49 is true. D1 and D3 point to separate objects, but the internals of those objects are the same, so it sort of makes intuitive sense that those would be dot equals. D4, the input on line 51 is actually null, and so certainly D1 is not dot equals to null. And then on that last line, line 54, that was actually kind of a trick question. So D4 is going to be null, and we can't call methods on null. We don't get to say null dot something. And here's an example of what it might look like to call equals on a dog. So now I've got 2 dogs, and I say D1 dot equals. And so inside of my dog class, I can write an equals method that takes in another dog, and I can compare, say, their ages. Can you imagine that this won't work if someone passes in null? If other dog is null, I'm going to get a null pointer exception here because I would try and say essentially null dot my age, and that's not going to work. But again, just as a review about how method calls work, inside of my non-static method equals here, I know it's not static because it doesn't say static, my this will refer to whatever D1 referred to, and my other dog will refer to whatever D3 referred to. Okay, I mentioned this on the first slide that actually when we write a dot equals method, because dot equals is provided in the Java object class, and every class extends the class object, we want to write a more generic equals method that takes in an object, and that will allow us to work with Java library classes that assume that they have a reference to an object. So here's a little bit of new syntax. So that input obj, is that an instance of a dog? So either is that a dog object or is that an object of a child class of dog? And if it's a child class of dog, then I can cast it to a dog, and then I can check the age and to see if those are the same. And otherwise, I can return false. And you can imagine if obj was null, then null is not an instance of dog. Obj isn't referencing a dog object, so we would hit this false case. And again, there, my this was going to be whatever D1 was, and my other dog, that was going to be whatever D3 was. And again, we can't call a method on null. So if I haven't given D4 a value, it's going to default to a null. And then D4.equals D1, that is an error, just like null.equals D1 is an error. And the specific error that we get is a Java null pointer exception. And these are awesome exceptions to get because it tells me exactly what line caused the null pointer exception, and I can click on it, and here it's line 45, and it'll jump me right to that line 45, and I can see that D4 must be null. You could imagine that system or out was null, but here I think the most plausible thing is D4 must be null. And so I think of these null pointer exceptions as actually a gift. Debugging can be really, really hard, but with these null pointer exceptions, I'm always going to get this link that I can click on that takes me right to the line of code. I can figure out what on that line is null, and then I have to figure out above it, gosh, how did that become null? But that's a way, way easier debugging problem. Okay, we're going to look at equal, equal, and dot equals with lists. And again here, I want you to pause the video to draw a picture of what this would look like. And you should pause here, but I'll keep going. So again, that equal equals mean they're literally the same object, and that dot equals is if they're equivalent. And these two lists are made in the exact same way, and we think they should be equivalent. And the really big idea here is that we define what equivalent means, and we have to write dot equals to define what equivalence is. Equal equal is built in, but dot equals we have to write. That's similar to the callback we've seen of toString. Okay, so based upon that code, we've got list 1 is the list with A and B in it. Then list 2 is an identical, list 2 is another list that has A and B in it. It's not identical because they're actually separate lists. And then list 3, that references the same thing as list 2 references. So those two variables are going to be identical or equal equal. So just zooming in on list 2 and list 3, those are literally referencing the same thing, so those are equal equal. Whereas list 1 and list 2, those are dot equal because they're equivalent. And again, the big idea here is that we have to write a dot equals method. Okay, and here's the equals method provided in the list node class. So again, if the object that gets passed in isn't an instance of a list, then you should just return false. So that handles the scenario where someone passes us null. And again, we want our equals method to always take in a type object. That allows it to work better with these library classes. And I think you could try and hide this code and write it yourself. I think that would be a good example problem to try and practice, and then the solution is provided for you here. The question I want to ask you is why s1.equals s2, or the not of s1.equals s2, why is that not an infinite loop? And I want you to take a note for yourself or pause it, and then I'll keep going. So S1 and S2 are of type data type. And so since we're calling a method on S1 and S1's type is data type, we're actually going to look inside the data type class for that dot equals method. So say data type was a string, we had made a list of strings, then we would look in the string class to try and find that dot equals method. If data type was a dog, when we see S1 dot equals, we would look in the dog class for a dot equals method. Okay, this is a big thing to be able to distinguish between equal, equal, and dot equals, and a major, major source of errors to accidentally use equal, equal when we really mean dot equals, and that is particularly the case when you're working with strings. With strings, you always, always, always want to use dot equals unless you're explicitly checking if it's null. With strings, you always want to use dot equals, and equal, equal, it'll sometimes act sort of strangely because Java tries to be sneaky with strings since they can't be modified. Two things that were not originally the same string, but they have their equivalent. Java will actually only have one copy, so sometimes equal equal won't give us the output that we expect. So with strings, you always, 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 always use equals. You want to call that method instead of using equal equal.